Okay, so if we can kind of frame your mind back to something important with this lesson that we've covered. We've been trying to find solutions to things that look like that, right? And so what we kind of learned the past couple days was we looked at our P's and our Q's. And P's were factors of 3, which were 1 and 3. And then Q's were factors of 2, which were 1 and 2. So your choices were plus or minus these over these, right? So we had 1 or 3 or 1/2 or 3/2. Here's what you may not know yet. This is super important. These are the only possible rational solutions. Give me something that might be, give me something that's irrational. Pi. Square root of 2. So it's possible that this could be a solution. It just means that if there were rational solutions, that's what these are. That's why it's called the rational roots theorem. Get my point? Today you're going to learn about real solutions. Suppose there was something that wasn't real. Give me an example of something that's not real. Yeah, like say 2 minus I. So what we talked about yesterday only has to do with these. What we talk about today only has to do with these. We eventually move on to the imaginary part, okay? So let's branch just a little bit further so we can understand about all real solutions. We move to this guy right here, okay? Descartes' rule of signs. Descartes was one of the great minds of the Renaissance era. He was able to look at philosophy, theology, science, mathematics. In fact, he's the one that's responsible for the Cartesian plane, which is our x and y axis. The argument can be made that he is really the father of our modern algebraic system, okay? Super smart guy, not enough credit given to him. And he does something today that's very important for us, and that's called his rule of signs. And his rule of signs says this: the number of positive real roots, so we want to just look at positive choices, the number of positive real roots of P of x is equal to the number of sign changes in P of x. So determine the number of sign changes in the polynomial, and that's the number of positive real solutions. The number of negative real roots is equal to the number of sign changes in P of negative x. So for the top one, we look at P of x. For the bottom one, we look at P of negative x. And for both of these, we say or less than by a factor of 2. I'll explain what that means in a second. So identify the possible number of positive and negative real solutions of the polynomial. So we're going to identify positive real. We're going to identify the number of negative real. And that's going to lead us to the total real. Is 3 positive or negative? Positive. Is 4 positive or negative in this situation? Negative. So do you agree that there was a sign change? And then does it change sign here? How about here? So how many sign changes were there? 3. So there are 3 positive real. Or there could be 1. You subtract off 2 every time. So suppose we would say, suppose we came up with 7 sign changes. It would be 7 or 5 or 3 or 1. Okay? You subtract off 2. So I'm going to show you why. Okay? I'll show you why. Are you ready for this? The y came up. I love the y. The y is good. says 3 or 1. So a cubic looks something like this, right? See how it crosses on the right side 3 times? It might look like that. Here's another option. It could look like this. See how that's on the right side as well? But it only crosses once. So this only crosses once. And I told you guys if it's x cubed, it has how many solutions? It has 3, but we only see 1. That means that there are 2 that are imaginary. Imaginary ones always come in pairs. And we can't tell by the sign change for sure if there's imaginary ones at this point. So it's 3 or 1. Better? So we're not really sure kind of which graph we're getting. Okay? So let's go back to this piece then and figure this out. Let's look at the number of negative ones. Please focus on this because if we don't, then I'm going to answer questions that become very, very redundant. Okay? I'm going to look at P of negative x. I can write it out, but I'm going to try not to because I think you guys are all going to see this. Okay? I plug in a negative x. When I take a negative x and cube it, it will become, everybody see this could be a negative 3x cubed? We all okay with that? Yes. Now, if I take the negative x and plug it into the squared, it will stay positive, and then the minus will be a minus 4x squared. You see that? And then if I plug the negative x in here, it will become negative 5x, and it'll be a minus 2. So what we can learn from this is when you plug in the negative x, if it's an odd, it will switch, right? And if it's an even, it will stay. So, you know, we've taken some time to plug in negative x's and negative y's, haven't we? And we've also taken time to look at odd powers and even powers. So hopefully that makes sense, everybody. You can do it quickly then. We all good? All right, so now, how many sign changes are there? There's none. So there are no negative reals. It does not cross on the left side of the x-axis. We don't even have to try any. We know it's not. There's no sign changes. They are always negative. So we can add these together. Suppose there were 3 positive real and 0 negative real. How many total real are there? 3. Suppose there was 1 positive real and 0 negative real. Then there would be, yeah, so there's 3 or 1 positive real. Or total real. See that? Yep. Let's try the next one. Positive real. I look at the sign changes. How many sign changes are there?
0.
None. There's no positive real solutions because there are no sign changes. There's none. Out of here. So in order to do the negative real, I must set up P of negative x. Do I leave it as negative x to the 4th or do I change it to positive? I leave it, right? If it's an even power, it's not going to switch. Okay, one more time right here. Yes. Okay, so I'll have negative x to the 4th. Is it going to stay a minus x squared or change to a plus x squared? Got a minus x squared and a minus 1. It's the same thing, isn't it? So how many sign changes are there now? There's none. There are no real roots, which means it doesn't cross the x-axis at all, does it? It probably looks something like that. It always stays below the x-axis, never crosses. So should we even try to find solutions? No. If we did, we would come up with 4 that are imaginary. See how we could tell all that information by just looking at the sign changes and nothing else? That's pretty cool. You're going to use that a lot moving forward, and we'll practice it again. Let's move on to something that's kind of neat, but you're not going to use it very much, so we're not going to spend a lot of time with it. So yesterday we looked at numbers like, say, negative 24, negative 12, negative 8, negative 6, negative 4, negative 3, negative 2, negative 1. 1, 2, 3, 4, 6, 8, 12, 24. Remember when we, no, you don't have to list them all down. Remember when we listed all those? It was like, oh my gosh, Mr. Gibbs, there's so many choices. Like, it's hurting my brain. I don't even want to plug them all in. We all been there, right? Wouldn't it be nice if we knew for sure that, like the only ones that were reasonable to choose would be, say, like these? I mean, it would be nice to narrow down the list. Descartes had a rule for that. He said if you're doing synthetic and you plug in a positive value, say like 2, if you plug in a positive value and you'll go ahead and work this through synthetic, if you come up with all values that are not negative, okay, so as long as they're positive or 0, he says that B is an upper bound. And what that means is that you shouldn't try any values higher than 2. Okay? So we're going to actually move straight to the example, then we'll do the other part. It says, show that this polynomial right here has zeros that lie between -3 and 2. So which one would be the upper bound and the lower bound? Which one's the upper? 2. Which one would be the lower? -3. So we're going to show that 2, that there's definitely none of that are higher than 2. And all we have to do it is just to run it through synthetic division. We've got 1, 0, -3, 2, and -5. Drop the 1, 2, 2, 4, 2, 4, 8, 3. Do you want an extra set of notes?
I'll do it at home.
Sounds good. All right. What do you notice about my output? They are all positive. Thus, 2 is an upper bound. That's pretty straightforward, is it not? Okay. I mean, you already know how to do synthetic division, right? You just got to recognize that they all come out positive. Let's look at a lower bound. What does a lower bound mean? Well, if you identify a negative number, you're wondering if it's a lower bound, okay? We'll say if A is negative, then if you get positive, negative, 0, positive, 0 doesn't count as a sign change, but notice how they all alternate signs. If you have alternate signs, then A is lower bound. Meaning you shouldn't try anything below that. So if you get alternating signs, then A's got to be a lower bound.
So 0 is fine, but it doesn't.
0 does not count as a sign change. Okay? So let's show that -3 is a lower bound. So I go -3, and I do 1, 0, -3, 2, -5. As I roll it through, I get a 1, a -3, 9, I get 48, and I get 43. What do you notice about all my results? Alternate sign. Thus, -3 is a lower bound. Meaning we have no business trying numbers like -6 and -12 and stuff like that. Okay? Now, I'll be honest, that looks like it would be really helpful. It doesn't come up that much for us. All right? It doesn't come up that much. But the positive reals and the negative reals, we use that all the time. We use that all the time.
What if it's not all positive for that?
Then we don't know. We can't say anything about it. Okay? All right, Sophie, are you ready to get an A on this next test?
Oh, yeah.
So then all you want to do is focus on this. You can do this, you are good to go. This is going to take all 3 lessons that we've had, I should say all 4 lessons, and it's going to combine it into one problem. And then we will actually build on this later on in other lessons. It's pretty cool. It says find all rational zeros of the polynomial and find the irrationals if there are any. Whenever you use the rational roots theorem, the upper and lower bounds, Descartes' rule of signs, the quadratic formula, or other factoring techniques, and sketch a graph. A lot of stuff involved, right? We're just going to list these. Positive real and negative real. And that will provide for us our total real. Okay? That is using that's using Descartes' rule of signs. So we've done that part right there. Okay? All right? Rational roots theorem, that's where we list our choices for the rational roots theorem. Okay? So I'm going to list my choices for the rational roots theorem. Find all the zeros. That's going to be our solutions in the end. Okay? Irrational zeros will be included in that. And upper and lower bound, if we need to use it, we'll use it. If the quadratic formula needs to be used, we'll use it. If we need a factor, we'll use it. And we will sketch a graph at the end. We'll put that graph right here. We are ready to go to work. This shows the complete work that we've put forth in this class so far. Okay? We start. How do I determine the number of positive real solutions to this polynomial? Sign changes. How many sign changes are there? 2. Goes from positive and negative, then negative to positive. We have 2. So 2 or 0. Very good. I check all of these on your test. Don't get lazy with me on them. So if you just write 2, it's a half point off. Okay? Got to write them all accurately. Negative real, I have to identify p of negative x. So, is it stay x to the third or is it negative x to the third? Negative x to the third, is it minus 3x squared or plus 3x squared? Minus 3x squared, is it plus 13x or minus 13x? Plus 13x, and it's a plus 15. Okay, so that's p of negative x. How many sign changes? There's 1. Yep, so you don't drop below 0, okay? So if we have 1, then we know definitively there is a negative solution, without a doubt. Not a guarantee that there's a positive, but we know there is a negative. So it has to cross on this side somewhere. We know that. The total real solutions will be 2 and 1, which is 3, or 0 and 1, which is 1. We've diagnosed the problem already. Now we list off our choices for the rational roots. I take my factors of the p's and my factors of the q's. What are going to be my choices? 3, 5, and 15. Good. What would you like to try? Negative 1? 1. Let's try 1. 1 cubed is 1. Minus 3. Minus 13 plus 15. Does that give for me 0? Yep. 1 minus 3 is negative 2. Negative 2 minus 13 is negative 15 plus 15 is 0. So that means that 1 works. Let's divide it out. 1, negative 3, negative 13, and 15. 1. 1, negative 2, negative 2, negative 15, negative 15, and 0. Sweet. So I have x minus 1, because 1 was a solution, x minus 1 is the factor, times x squared minus 2x minus 15. So it does factor. We didn't see that it factored, but it does. Does x squared minus 2x minus 15 factor in a way that you see?
Yeah.
2x minus 5 and x plus 3. So I get solutions of I don't care what order you write them all. Make sure I see that there are 3. This is the absolute best part. If you can't think that this is cool, then I don't know what to do for you, folks. Look at these. How many negative ones do I have? I have 1 negative 1. It promised us ahead of time that we would have that, didn't it? How many positive do we have? We have 2 for our total of 3. And that even goes even further. We'll be able to diagnose more when you guys get to the next lesson. I can now graph it. 1, 2, 3, 4, 5, and 1, 2, 3. I plot the negative, what do we have? Negative 3, positive 1, and positive 5. And it looks like that. And by the way, that's no big deal to you because you got the internet, you got your calculator, you got all sorts of things that can produce that. DesCartes, that was back when they used candles for lighting, folks. That was year 1500 for crying out loud. And he's doing all of this to produce an excellent shape of a graph. Quickly, efficiently, without making an XY table, without using a calculator, without using the internet. Yeah. Nope. 1. Yep. Better? Good. Flip it on over. Last one. Scared?
No.
Petrified?
No.
Terrified? Positive real? Negative real? Total real? By the way, I will have all this listed for you on the test. You don't need to write it out every time. But I will say, you don't get an hour and 40 minutes to do the test. So you got to be able to go through these problems with a fair pace. You can't sit there for 20 minutes and think about one problem. Okay? Part of it is that you got to be prepared for the next class. As you guys take calculus, again, we got to keep a certain pace. So I start with the positive real. Sure you are. Next year in college. Good for you. All right. How many sign changes? There are 4. Good. So 4 or 2 or 0. Okay? Drop it all the way down to 0 if you can. Or 1. Okay? So now in order to determine negative real, I got to write out P of negative x. Negative x to the 5th minus 3x to the 4th plus x cubed sweet. Sign changes. 1. So we're guaranteed 1 negative just like in the last one. So there's going to be 5 or 3 or 1. Now you're saying to yourself, Mr. Gans, seriously, you gave us x to the 5th? Yeah, I did. I did that. But look at the last number I give you. I just give you 4. That's pretty nice, isn't it? Yeah. We're just going plus or minus 1, plus or minus 2, plus or minus 4. So out of an infinite set of numbers, we've given you guys just 6 that you need to choose from. Not bad at all. Should we try 1? 1 minus 3. Negative 2 minus 1. Negative 3 plus 11. 8 minus 12. Negative 4 plus 4. 0. Looks like 1 works, doesn't it? Let's try 1. 1, negative 3, negative 1, 11, negative 12, 4. Some of you are saying, Mr. Gens, I don't like trying to plug all that in. Then go ahead. Just start with synthetic, and you should come out with 0 as a remainder if it works. Yep, either way. People use both methods on the test. Some people plug it in. Some people roll through synthetic right away. It's up to you. Free country. Do what you want. Did it work? is it possible that 1 would work again?
Yeah.
It is. It's possible. Do you want to try it? So at this point, I'm just going to try 1 again. So I know 1 works once. Let's see if it works twice. 1, 1, negative 1, 1, 4, 4, 4, 4, 0. Did it work again? Now, okay, you actually have a couple options at this point. You got 3 options. Number 1 is to try 1 again. What would be another option? Try a different option. Okay, try a different number. Anybody know what the other option is here? It does factor. If you guys don't see it, this actually factors by grouping here if you were to write it out. So people did not see that right away, so I'm going to go ahead and try 1 again, but I want to be clear that this is a grouping operation right now. It'd be x cubed minus x squared minus 4x plus 4. It does group. But let's say you didn't see that. You want to try 1 again. Go ahead. 1, 1, 0, 0, negative 4, negative 4, 0. So did 1 work again? So 1 worked how many times? 3. So that means this factored to x minus 1 quantity cubed. It worked 3 times x squared minus 4. Does that factor? X minus 1 cubed times x plus 2 times x minus 2. So my solutions are, please make sure you list all 5 of them. Again, the best part, how many positive do you have? There's 4 positive there, aren't there? There's 1 negative for a total of 5. And they are all parts of your choices sitting right there. Last thing I'm going to do is sketch this graph. Negative 2, positive 2, and 1. It's an x to the 5th, and it's positive. So that means it finishes going, x to the 5th finishes going up, and it starts facing down. And it is a triple root at 1. See if you can draw it, triple root at 1. Yeah.
You'd be able to tell I have a triple.
These are, you guys have, yep, good, yep, fair enough.
My graph predicts
I'm like,
Yep.
I'm like, I think this is all. Especially when I was late,
Oh my god.
I've been used to like,
Honey.
I just gasped the rate this time. I did a lot.
Really? Okay, there I go. Oh my gosh. This graph makes me scared.
I'm going there. Okay, I'm liking that one. Okay, what do you think? Close enough? Yeah. So if you can do that, if you guys are like, hey, Mr. Gans, like I understood that. Like I can identify the positive and negative. I know I come up with the total. I get the rational roots. I get how to find them and list them. I can sketch a graph. You are ready to get an A on the test. Now, you guys, I want to be clear here because you guys don't see teachers this way sometimes, and I want to make sure that you do. Rachel, do you have a goal in hockey this year?
Yeah.
Give me a goal.
Go to state.
Go to state, okay? You've set that goal. In a given game, do you have a goal for how many pucks you're going to let through that net?
Usually like a save percentage.
Usually a save percentage, okay? All right. And you want to make that goal, right? And you're critical on yourself, right? And there are times you could say, well, if my defense would have played better, then I would have had a better percentage. Do you agree? You need a teamwork here, right? I've got a goal too, folks. Here's my goal. Half the class scores a 94% or higher on this test. Do you like my goal?
Yeah.
Because it also produces some good results for you, doesn't it? Can I do this goal alone? No, I can't. I need your help, okay? But I'm going to try to do my best. I think it's reasonable. Half the class, 94% or higher. I kid you not. You can do it. Okay? Take out your homework so I can give you the direction. Okay, as you look at your next set, just to be clear, problems 1, 2, 3, and 4, you don't have to find all the solutions. You don't have to graph all of them. You just need to list the positive, the negative, and the total. Do you see that? Yeah. By the way, number 4 is optional. Sometimes people don't understand number 4 very well. You could just circle it or put an optional next to number 4 and choose whether or not you want to engage there. Numbers 5, 6, 7, 8. That's where you show it's an upper bound or lower bound. How again do we show it's an upper or lower bound? We just run it through synthetic division. That should take you a total of what? Like for all these, like 4 minutes? Like that could go fast, right? And you just need to see if it's alternating sign or if it's same sign, right? That's it. I shouldn't say same sign, I should say all positive. So the front page should go rather quickly. The second page, I just have 2 problems. Just like we had in class, okay? Sometimes people skip these 2 problems, or they can't remember because they say there's a lot involved. Folks, if you were like behind on your homework and you're like, shoot, like I gotta get ready for this test and what should I do? These are the first 2 things I would do. This is the most important thing to do. Like this tells you whether or not you're gonna get an A on the test. You get my point? So don't skip those 2. That's the most important. Skip stuff on the front for crying out loud. If you're, don't skip anything. But if you're going to skip something, don't skip that for crying out loud. We got my point?
Yes.
Okay, so lesson tomorrow, right?
Yep. Wait, people don't get it.
No lesson tomorrow, folks. You have the entire hour to work tomorrow. I will not interrupt your time.
You know how I talked about that leaving